Let's simplify this nasty looking Boolean algebraic expression. First, let's plug a in for all of the num greater than 0 terms. And let's plug b in for all of the temp less than or equal to zeros. Rewrite the rest of the expression carefully. And we're left with this. I'm going to apply De Morgan's law to this not that's in front of this set of parentheses. The or changes to an and this not then distributes to the a and the b. Keep this set of parentheses there in order to preserve the order of operations that may be necessary. Okay, I'm going to rewrite everything else. Don't do too much in one step. I think that's what we currently have. According to order of operations, you always do ands before ors. So I don't think this set of parentheses is necessary. So I'm going to rewrite everything with just the one outer set of parentheses. So pretty much all I did so far was I simplified the original expression by putting in a's and b's. And I applied De Morgan's law to a spot where I could. Now, let's work inside this one set of parentheses, ignoring the not for now. We have something being anded with the opposite of something, and overall the whole thing is being or'd with that not of something being anded with the opposite of the something else. I'm sure there's a Boolean algebraic identity out there somewhere that precisely simplifies this, but with just raw brain power and logic and brute force thinking, I think we can gut through this and simplify all of this. I think the b is a non-player. If b is a 0, all of this wipes out to 0. By the way, 0 is the same thing as false. And since and is like multiplication, 0 times anything is 0. But if b is 0, then over here this is a 1, a true. And that 1 times something is the something itself. So I think all of this in here hinges on not a. It doesn't matter what b is. We can simplify this inner parentheses area as simply this. This not b and this b sort of cancel out, and we're left with the not of all this. Well, this inside parentheses part simplifies to just not a, because 1 plus 1 is 1, and 0 plus 0 is 0. Remember that or is like addition. And 1 plus 1 is equal to 1 in Boolean algebra. There is no 2 or 3. So we're left with the not of an a. These two nots cancel out, and we're left with just a, which, from the original substitution, is simply num greater than 0. There are many other ways to have done this problem. You could have used the not and flipped this greater than to a less than or equal to 0. You could have rearranged some of this stuff in a formal way. But all paths that are correct would have led to the simplification of just a, which again is num greater than 0.